Hi, I am Ihab Gabashne, PhD student at Purdue. In this talk, I will present our work called Dragonfly, Higher Perceptual Quality for Continuous 360-degree Video Playback. This is a joint work between Purdue University and the University of Southern California. Now, today, video has the dominant share of internet traffic. And this tremendous success in videos actually has led to the advent of new forms of videos, such as volumetric videos, AR/VR videos, and the case of our talk today, 360 videos. Now, 360 video is different than the traditional form of video, which is the most popular form we have today, in the sense that users passively consume the content of traditional videos. While in 360, we are expanding the region of view to cover the full surrounding of camera capture, allowing the user to explore different paths within the video and be more actively engaging with the content. Now, with this, question arises is how to stream 360 video to enable this immersive experience. Currently, there are mainly two ways to stream 360. First is the most common, widely deployed way in the industry, which is simply streaming the full 360 video back to the user irrespective of their motion, following the traditional streaming methodology. Now, while this is simple, the main challenge here is that 360 video can grow significantly in size, with a bandwidth requirement far exceeds our average US broadband bandwidth. Now, to overcome this bandwidth challenge, recent work proposed alternative approach, which involves predicting user motion until the transmission of relevant portion of the video based on these predictions. Now, in order for them to achieve this, they had to introduce the video tiling process. This is mainly, now what is video tiling is mainly taken the 360 video and spatially segment it into smaller portions, and then take each portion or region and temporarily you would segment it into a couple of seconds of duration, called tiles. Now, although this approach significantly reduces the bandwidth requirement, the issue is that they still treat 360 as conventional adaptive bitrate algorithm, in which they try to optimize the quality of relevant tiles and minimize installs. And they will still actually stall if there's only single relevant tile is missing. Now, the problem in install in 360 video is that it has two conflicting root causes. First one, it is actually motion misprediction. Now, for this, we found that the median accuracy for small look ahead of 3 seconds is only 25%. And this uncertainty will lead to not only rebuffering, but also optimizing the quality of irrelevant tiles. Now, the other root cause is actually mispredicting the bandwidth dips. Now, rebuffering is an undesirable event for all sort of videos, but it's actually bigger of a problem for 360 video. Now, this is because the user can still actually make some movement during rebuffering, which would badly hurt their immersive experience. In fact, here is an example from one of the snapshots from our user study sessions, showing the user movement during rebuffering events. And you can see here that the user can still make quite a movement of more than 60 degrees. And this can lead to cascade stalls, which would negatively hurt the interactivity, which is the main objective of the full 360 video. Now, an alternative model to keep track of the user motion is the SCIB model. Now, the simplest form of which would be the naive skip. Now, this is mainly fetching all relevant tiles, and if the tile is missing, you just skip it if it doesn't really arrive by the deadline. Now, here, it's worth mentioning that the naive skip doesn't really involve any form of decision to deliberately miss tiles, and this can be a problem. For instance, let's assume the user is missing a couple of tiles at the periphery, and also which are marked in red. And so simultaneously, it's missing more critical tiles for the next chunk duration. Now, the decision that the naive skip will do here is it would rather fetch those tiles in the periphery first because of their imminent deadline, although they may actually arrive after their rendering deadline, at which they will be useless. And which will also lead to the cascade of arrival of the critical tiles, prolonging the duration of incomplete viewports. As a result, naive skip could lead to poor perceptual quality and unacceptable user experience. Now, another way to perform skip is to conduct it proactively by prioritizing tiles based on factors relevant to the user experience other than just their deadline. So in here, we may sometimes make decision not to fetch tiles. Back to our example. So proactive skip would rather not requesting these tiles in the periphery to receive the critical tiles on time. Now this would lead to higher perceptual quality and more interactive user experience, and would shorten the duration of incomplete viewports. Now, for this, we propose Dragonfly, which is a system that's completely designed for continuous playback. So it would skip missing tiles proactively to maintain interactivity. Now, in order for it to do so, it relies on a utility-driven model to determine which tiles to fetch and which not to fetch, and what quality for those to be fetched, and even in what order to be fetched. Now, we validated Dragonfly with a user study and extensive emulation, and some of the results from these experiments is that users rated 65% of Dragonfly sessions as excellent or good or excellent, while only just 16% for the state-of-the-art with this rating. And also we found that Dragonfly improved the median viewport quality by 1.25 to 2.8x in relative to other systems. Now, what is exactly Dragonfly? So first, let me just try and quickly explain the design key of Dragonfly, which is the utility-driven model. Now here, first thing we do is we find whether the tile is relevant for each viewport in our prediction window. Then we try to answer a couple of questions, starting with how many frames or viewports would benefit from fetching the tile. And we also interested in knowing how central that tile relative to the viewport, whether that tile is in the center, making it more critical, or it's just in the periphery. And also, we are interested to know what would be the value of the tile if it is estimated to arrive by time t. Now, after we compute the tile utility, we pass them along with the estimated bandwidth to the tile scheduler. Now, the tile scheduler then will determine which tiles to fetch, in what quality, and in what order. Well, the goal is to maximize the total utility for all the tiles to be fetched. Now, finding the optimal solution is an integer programming problem for which we use a greedy heuristic algorithm to solve. Now, you can find the details of the algorithm in our paper. Now, for evaluation, we did a user study and extensive evaluation. Now, for the sake of the time, I will only be able to go over some of the results from our user study only. Now, for our user study, we had 26 participants, each watching 5 videos, each streamed by 3 different schemes: Dragonfly, Flare, Pano, which is the state-of-the-art. Now, here you can find the distribution of participants' opinion score about all sessions, grouped by scheme, with opinion score 1 means poor experience, 5 being excellent. Now, looking into the percentage of sessions with 4 or more rating, you can see that the majority, 65% Dragonfly sessions, had that rating, while only minority of Pano had the same rating. Now, we dive a bit deeper to understand the reasoning behind the user score, and we did that by summarizing the key observation from the participants' feedback, which we collected during the study. Now, looking into the reactivity and quality feedback, we can see the majority of users' reactivity feedback, indicating Dragonfly being highly reactive to their motion, and it also managed to stream high-quality sessions. Now, to conclude, we are proposing Dragonfly, new 360-degree system that proactively skip tiles rather than installing the playback to maintain interactivity. And it also is using utility-driven model that capture factors relevant to user experience to determine which tiles to fetch at what quality and in what order. Our results showing that the users from our study rated 65 or the majority of Dragonfly sessions with opinion score of 4 or higher. That's good or excellent experience, while only 13–16% for other systems. And also, we are able to improve the median viewport quality by 1.25 to 2.8x's relative to other systems. We also releasing the Dragonfly source code along with all other systems you see in our evaluation. Please check it out and let us know. Last, I would like to thank all of you for watching this talk.